So here we have the exponential function e raised to the power of 4t. So let's find out the Laplace transform of f of t. So that will be equals to Laplace transform of e raised to the power of 4t, which will be equals to 1 over s minus 4. So here we are using the fact that Laplace transform of e raised to the power of at is equals to 1 over s minus a. Now here the given Laplace transform is going to exist when the denominator s minus 4 is greater than 0, or simply put s is greater than 4. Let's do another problem. So here we have the function t raised to the power of 7. So Laplace transform of t raised to the power of 7. So we're going to here use the fact that Laplace transform of t raised to the power of n is equals to n factorial over s raised to the power of n plus 1, where n is a natural number. So that means we have 7 factorial divided by s raised to the power of 7 plus 1, which is 8, and this Laplace transform is going to exist for s greater than 0. So this is the Laplace transform. Let's do another. So here we have the function 3e raised to the power of 2t plus 4e raised to the power of negative 3t. So Laplace transform of f of t will be equals to, so we're going to use the linearity property of Laplace transform. So we're 3 times the Laplace transform of the first term. So we have Laplace transform of e raised to the power of 2t plus 4 times the Laplace transform of the second term, which is e raised to the power of negative 3t, which will be equals to 3 times the Laplace transform of e raised to the power of 2t will be 1 over s minus 2, plus 4 times the Laplace transform of e raised to the power of negative 3t will be 1 over s minus of negative 3. So that will be equals to 3 over s minus 2 plus 4 divided by s plus 3. So this is the Laplace transform of the given function. Now we also have to check for what values of s the given Laplace transform is going to exist. So s minus 2 must be greater than 0, which implies that s must be greater than 2. And also s plus 3 must be greater than 0, which implies that s must be greater than negative 3. So combining these two inequalities, we have s greater than 2, for which the given Laplace transform is going to exist. Let's move on to the next question. So here we have the function 5 times e raised to the power of 2t minus 3 whole square. I need to determine the Laplace transform of the given function. But before that, we're going to expand it. So we have 5 times e raised to the power of 2t whole squared minus 2 times of 5e raised to the power of 2t times 3 plus 3 squared. So that will be 5 squared, which is 25, times e raised to the power of 2t times 2, so that will be 4t minus 2 times 5, which is 10. So we have 10 times e raised to the power of 2t. So there's a 3 as well, so 2 times 5 times 10, so that will be 30 plus 3 squared, which is 9. So Laplace transform of f of t will be equals to 25 times the Laplace transform of e raised to the power of 4t minus 30 times the Laplace transform of e raised to the power of 2t plus 9 times the Laplace transform of 1. So we have 25 times e raised to the power of 40. The Laplace transform will be 1 over s minus 4 minus 30 times 1 over s minus 2 plus 9 times Laplace transform of 1 is 1 over s. So we have 25 over s minus 4 minus 30 over s minus 2 plus 9 over s. So this is the required Laplace transform, and this transform is going to exist if s minus 4 is greater than 0, which implies that s must be greater than 4, exist for s minus 2 greater than 0, which means that s must be greater than 2 for the second term, and for the third term we have s must be greater than 0. So combining the three inequalities, so we have s must be greater than 4 for the given Laplace transform to exist. Let's move on to the next question. So we have the function 1 over square root of pi times t. So we need to determine the Laplace transform of the given function f of t. So first, what we can do is we can rewrite the given function as 1 over square root of pi times square root of t, which will be equals to 1 over square root of pi times t raised to the power of half, or we can say it's t raised to the power of negative half divided by square root of pi. So we're going to determine the Laplace transform of t raised to the power of negative half divided by square root of pi. Now 1 over pi square root of pi being a constant, we can pull it out of the operator. So we have 1 over square root of pi times the Laplace transform of t raised to the power negative half. The negative half is a rational number, so here we're going to use the Laplace transform of t raised to the power of p, where p is a rational number. It's given by gamma p plus 1 divided by s raised to the power of p plus 1. So we have 1 over square root of pi multiplied to the gamma minus half plus 1 divided by s raised to the power negative half plus 1. So which will be 1 over square root of pi times the gamma of square root of negative half plus 1 will be positive half divided by s raised to the power of half. Now we know that gamma of half is equals to square root of pi, so that gives us square root of pi divided by square root of pi times square root of s. So the power square root of pi gets cancelled and we are left with 1 over square root of s. So this is the Laplace transform of the given function, which is going to exist for s greater than 0. Let's move on to the next question. So here we have the function t raised to the power of 2/3 minus 1 over t raised to the power of 1/3 whole squared, and we need to find its Laplace transform. But before that, we are going to expand the given function. So we can rewrite this function as t raised to the power of 2/3 minus t raised to the power of negative 1/3 whole squared. Now expanding it, we're going to get t raised to the power of 2/3 whole squared minus 2 times t raised to the power of 2/3 times t raised to the power of negative 1/3 plus t raised to the power of negative 1/3 whole squared. So that gives us t raised to the power of 2/3 times 2 will be 4/3 minus 2 times t raised to the power of 2/3 minus 1/3 plus t raised to the power of negative 2 over 3. So we have t raised to the power of 4/3 minus 2 times 2/3 minus 1/3 will be t raised to the power of 1/3 plus t raised to the power of negative 2/3. So now we find the Laplace transform of the given function f of t. So that will be equals to Laplace transform of t raised to the power 4/3 minus 2 times Laplace transform of t raised to the power 1/3 plus Laplace transform of t raised to the power of negative 2/3, which will be equals to, so the 4 over 3 being a rational number, so we have gamma 4 over 3 plus 1 divided by s raised to the power of 4/3 plus 1 minus 2 times gamma 1/3 plus 1 divided by s raised to the power of 1/3 plus 1 plus gamma negative 2/3 plus 1 divided by s raised to the power of negative 2/3 plus 1. So we have for gamma 4/3 plus 1, that will be 4/3 of gamma 4/3 over s raised to the power of 4/3 plus 1 will be 7/3 minus 2 times 1/3 of gamma 1/3 divided by s raised to the power of 1/3 plus 1 will be 4/3 plus gamma negative 2/3 plus 1 is gamma 1/3 divided by s raised to the power of 1/3. So we have 4/3 times, so gamma 4/3 can be also rewritten as 1/3 plus 1 divided by s raised to the power of 7/3 minus 2 times gamma of 1/3 divided by 3 times s raised to the power of 4/3 plus gamma 1/3 divided by s raised to the power of 1/3. So we have 4 times 4 over 3 times gamma of 1/3 plus 1 will be 1/3 multiplied to gamma 1/3 divided by s raised to the power of 7 over 3 minus 2 times gamma 1/3 divided by 3 times s raised to the power of 4/3 plus gamma 1/3 divided by s raised to the power of 1/3. So we have 4 multiplied to gamma 1/3 divided by 9 times s raised to the power of 7/3 minus 2 times gamma 1/3 divided by 3 times s raised to the power of 4/3 plus gamma 1/3 divided by s raised to the power of 1/3. So this is the Laplace transform of the given function, which is going to exist for s greater than 0. Let's do another problem. So we have the given function and we need to determine its Laplace transform. So let us begin by first simplifying the given expression. So we begin with the numerator. So we have square root of t multiplied to 2 minus square root of t plus 1 multiplied to 2 minus square root of t all divided by square root of t, which will give us 2 times square root of t minus square root of t multiplied to square root of t will be simply t plus 2 minus square root of t divided by square root of t. So 2 times square root of t minus square root of t will give us square root of t minus t plus 2 divided by square root of t. We're going to divide each term by square root of t in the denominator. So we have square root of t divided by square root of t, so that will be 1 minus t over square root of t, which can be written as t raised to the power of half, plus 2 divided by t raised to the power of half. So we have 1 minus, so the numerator we have t raised to the power of 1, so t raised to the power of 1 minus of half, so that will be t raised to the power of half plus 2 times t raised to the power of negative half. So this is the simplified form of the given function f of t. Now let us find out the Laplace transform of the given function. So we have Laplace transform of f of t, so that will be equals to Laplace transform of 1 minus Laplace transform of t raised to the power of half plus 2 times the Laplace transform of t raised to the power of negative half. So Laplace transform of 1 is 1 over s minus Laplace transform of t raised to the power of half will be gamma half plus 1 divided by s raised to the power of half plus 1 plus 2 times gamma negative half plus 1 divided by s raised to the power of negative half plus 1. which will be equals to 1 over s minus, so gamma of half plus 1 will be half times gamma half divided by s raised to the power of half plus 1, which is 3 over 2, plus 2 times gamma of negative half plus 1 will be positive half divided by s raised to the power of positive half. So that gives us 1 over s minus, so we have gamma of half, so that will be square root of pi divided by 2 times s raised to the power of 3 over 2 plus 2 times gamma of pi, so that will be 2 times square root of gamma of half is square root of pi, so we have 2 times square root of pi divided by s raised to the power of half, so that is simply square root of s. So this is the required Laplace transform, which is going to exist for values of s greater than 0.